try a simple calculation on two sample t-test. So the situation is, or the question is, UITM received information from the Office of Facility that two contractors had so far completed their construction works for 2 units of students' residential. The Office of Facility claims that contractor A had taken shorter time every day to complete their work in accordance to agreed working schedule. So we have two contractor A and contractor B. So UITM would like to test the hypothesis whether is it true that contractor A is taken shorter time than contractor B to complete their construction work. So UITM will have to make a decision whether they would like to appoint contractor A or contractor B in the future. So let us write down our hypothesis. So we will always start with our alternate hypothesis or H1. Every time you are doing two sample, you need to start writing your hypothesis based on H1. So H1 is mu1, which is mean of contractor 1, is smaller than mu2. Mu2 represents contractor B, sample of contractor B. In other words, the mean of contractor 1 is smaller than the mean of contractor B. And this is consistent with the statement here saying that contractor A is taken shorter time to complete their construction work. So HO is mu1 is bigger or equal to the mean of mu2. Since if you look at the alternate hypothesis, it is smaller than, it's going to be a lower one-tail test. Over here, I have a data on two samples from each of the contractors. I have a data of contractor A and the time taken every day to complete their work. So this is a data for 26 days. So two samples, yeah, contractor A and contractor B. Good. So let us conduct our hypothesis test. So you go to your data in the menu, select data analysis, and we will select t-test, two samples assuming unequal variances. So this is the common test that you have to select every time you want to conduct your hypothesis test for two samples, which is two sample assuming unequal variances. So click OK. So over here, we have the input that you have to select. So we have two variables here. The first one is for the first sample, which is for contractor A. So the variable range should be, you select the whole range from day 1 to day 26. Okay, up to here. And then select sample B or contractor B. Contractor B starts here up to here. Okay, so we have selected the range for contractor A and the range for contractor B. Hypothesized mean difference should be 0. Labels. Okay, alpha or significant level. We would like to select, or we normally will select 5% significant level or 0.05. Okay, output range. Where do you want to have your output in the worksheet? So let's say I would like to have it here. I want to put it here. Put it here. Okay, now click OK. So this is the output from our data analysis, two sample unequal variances. So let's make it slightly bigger. Okay, two sample assuming unequal variances. Let's highlight it a bit, put in green. So the output, which is that must be our focus, is the t-stat value. Let's highlight it in yellow. The t critical value, one tail, and also the p value, one tail, which is here. So put it in green. So we know that this is lower one tail test. So first we have to do our hypothesis test using critical value approach, where you have to compare your t-stat with the t critical value. So if you look at your distribution at the lower tail, the critical value is negative 1.67 here. Why it is negative, whereas here it is positive? Because it is lower one tail, you have to make it negative. Okay, so the critical value is negative 1.67, and from our output here, we know that our t-statistic is negative 2.86. So is the value of t-stat, is it within rejection region? So please draw your distribution and put the value of t-stat and compare with the value of critical value. So you can see that the value of t-statistic here is within the rejection region because it is smaller. T-stat is smaller than the critical value. So what does that mean? Reject HO. And you can say that there is no sufficient evidence to support HO and accept H1. So the conclusion from our critical value approach test is that HO is rejected and H1 is true, meaning that it is true that the mean hours taken by contractor A is actually shorter than the mean hours taken by contractor B to complete the construction work. So what is claimed here is actually true. So another approach that you can use for your hypothesis two sample testing is p-value approach, where you compare p-value with the significant value. So I've highlighted here that our p-value is 0.003. Okay, p-value is actually 0.03, which is, so we can see that our p-value here is actually smaller than the alpha or significant value, 0.05. So what conclusion you can make since the p-value is smaller than significant value? So we know that from our slide, please refer back to our previous slide. We reject HO and accept H1 because p-value is smaller than of value. So the p-value approach is actually consistent with the critical value approach, where both approaches indicates that reject H0 and accept H1.